Hello, my name is Gitas, and this is the screencast of my third year project Generative Stained-Glass Window Designs. The supervisor of this project, Toby Howard. Stained glass is an art form which continued to be popular throughout its thousand-year history, decorating mostly windows of churches and other significant religious buildings. Traditional stained glass window designs have unique characteristics, including careful choices of shapes and colors to create a pleasant view. Generally speaking, there are two types of designs: abstract and representational. Abstract ones contain geometric designs with repeating shapes, sizes, and colors, and most importantly are based on symmetry, while representational ones demonstrate pictorial views and biblical scenes. During this project, I developed a system capable of generating a wide range of abstract stained glass window designs. Now, let's have a look how the generative part of the application works. To achieve a continuous design, a kaleidoscope effect has been implemented, allowing to generate symmetrical geometric designs. The way it works is by generating only a fraction of the design, just like this piece, and then, by transforming its copies in a systematic way, a continuous design can be achieved, and thus generating an enjoyable view of the stained glass. For this project, in order to generate inner shapes of the design, a line function and a Bezier curve has been implemented, which enables to achieve a wide range of geometric figures. The main reason why I've decided to pursue with these functions is that they both share a common characteristic, have well-defined starting and ending coordinates. With the line function, it is straightforward. Starting and ending points need to be connected with a straight line. A Bezier curve works a little bit different. It has two additional control points that bends the line towards them, acting as magnets. Now let's go through the process of generation of the design to see how application operates. Every time a user presses a button New Design, we always start with a single shape just like this one. Along its borders, marked with a red line, spa points are generated. On each run, out of all spa points of the shape, two will be chosen, which will indicate the starting and ending coordinates of a stroke. Here we can see that these two red points have been picked and connected with the Bezier curve that divided the original parent shape into two shapes. At this point, the design consists of two shapes. On the next run, a parent shape needs to be chosen again, which will be used to generate another pair of shapes. In this case, the red shape has been chosen, and the red line indicates all available spa points along the border of the shape. So in this case, these two red spa points have been picked, and they were connected with a line function. And we continue the process over and over again until the required number of shapes are generated. And if we use the kaleidoscope transformation for this piece of the circle, we get such a design. The red line here indicates the piece from the previous slide that has been generated. The design from the previous slide doesn't really look like a stained glass yet, as it lacks the visual effects. To improve the quality of an image, following implementations have been introduced to make the design look as realistic as possible. Firstly, lighting has been introduced into the scene. After many different combinations and variations of lighting types, I've decided to stick to only directional light, as I found it works the best. Directional light mimics the light that you would get from the sun. It comes from one direction, which exists infinitely far away. Furthermore, a skybox was implemented, which is a background for the scene. This creates an illusion of having a design in the real world, and no matter how you rotate the camera, you will always see a background image. Skybox dramatically improved the quality of visual representation of the design and made the stained glass look more realistic. Last on the list is three-dimensional stroke. Instead of using a flat line to draw inner strokes of a design, I've decided to implement a three-dimensional one, which is in fact a pipe. By doing so, the feeling of the design being 3D has been enhanced dramatically. It is important to mention that the application is not fully random, as a number of different parameters are implemented that the user have access to in order to manipulate the generative part of the design. This includes the detail where the higher the value, the more shapes will be fitted on the design, a lines and curves ratio, which sets the distribution of lines and Bezier curves in the design. 0 means only lines will be used to generate the design, while 100 only Bezier curves. A parameter balance sets the smallest possible size of a single shape on the design. The lower the value, the bigger the area difference will be between the smallest and largest shapes. The higher the value means that shapes will be approximately the same size. With a colorfulness parameter, a user is able to set how colorful the design will be. If value is set to 0, all shapes will have the same color, and if we set it to 100, that means that all shapes will have a unique one. Lastly, an angle of a starting shape can be set that controls the frequency of a pattern of the design. The default value is 30 degrees, however, it can be set to 15, 45, and 60 as well. Before we finish, there's one last thing. If by any chance you generate a good-looking design, you always have a chance to save the image. All you have to do is press P. And this will mark the end of the screencast. Thank you very much for listening.